How does the countercurrent multiplier in the loop of Henle establish and maintain a medullary osmotic gradient? And how does this gradient enable the kidneys to produce concentrated urine and conserve water?
The countercurrent multiplier is a system that allows the kidneys to create a salty or hyperosmotic environment deep in the medulla. This gradient is absolutely essential for the body to conserve water and produce concentrated urine. It happens mainly in the long loops of Henle in the juxtamedullary nephrons. To understand it, let's follow the filtrate step by step through the descending limb, the ascending limb, and into the medullary interstitial fluid around them. As the filtrate enters the descending limb of the loop of Henle, this segment is permeable to water, but not to salts like sodium or chloride. The surrounding medullary interstitial fluid is very salty because of previous actions of this system, so water leaves the filtrate by osmosis. As more water exits, the filtrate becomes more and more concentrated the deeper it goes into the medulla. Then, the filtrate makes a turn and enters the ascending limb, which behaves in the exact opposite way. The ascending limb is impermeable to water, but it actively transports sodium, potassium, and chloride ions out into the interstitial fluid. Because water can't follow, the filtrate becomes more dilute as it rises back up toward the cortex. At the same time, the medullary interstitial fluid becomes saltier. This creates a difference in osmolarity, which is the concentration of dissolved particles in a solution. In this case, around 200 milliosmoles per liter, meaning the solution has about 200 dissolved particles per liter that contribute to osmotic pressure. This gradient occurs between the filtrate inside the ascending limb and the surrounding interstitial fluid. As new filtrate keeps flowing in, this small difference is multiplied down the length of the loop, creating a strong osmotic gradient through the entire medulla, from roughly 300 milliosmoles at the cortex to about 1200 milliosmoles deep in the medulla. That's why it's called a countercurrent multiplier. Fluid flows in opposite directions, and a small effect is multiplied into a large one. Meanwhile, the vasa recta, a network of capillaries that runs alongside the loop of Henle, acts as the countercurrent exchanger. It doesn't create the gradient, it preserves it. As blood descends into the medulla, it picks up salt and loses water. As it ascends again, it gives salt back and reabsorbs water. This prevents the gradient from being washed away by blood flow. This entire system is crucial because it sets the stage for the collecting ducts. When antidiuretic hormone, or ADH, is present, the collecting ducts become permeable to water. Now, water can leave the filtrate and move into the salty medullary interstitial fluid, concentrating the urine. Without the countercurrent multiplier system, we would lose large amounts of water in dilute urine and would dehydrate quickly.